Hello, good morning. So the second in our lectures on management systems of tropical forests for timber production. In this lecture we're going to be talking about natural regeneration and restoration tropical management systems and reduced impact logging, which generally supports natural regeneration management systems of timber production. We're going to go through and see what are the pluses and the minuses of natural regeneration and restoration timber management systems, and we're going to take a look at how natural regeneration systems are supported by reduced impact logging. Okay, first of all, natural regeneration timber management systems. Now, we talked about clearing systems of timber production in forests before. Basically, clearing systems aim to at least retain part of the natural ecosystem processes, but aim to also manipulate the forest to a certain degree to promote timber species. Now, natural regeneration management systems are down the other end of the spectrum of clearing systems from plantation systems, in that they call for little or no manipulation of the forest and for maximum preservation of the natural ecosystem processes. So there is very few inputs in natural regeneration system in terms of providing seedlings for regeneration, tending during growth between harvesting cycles, and the amount of timber which can be harvested from the forest. So with natural regeneration systems, the name natural regeneration comes from the fact that seedlings are provided naturally. There is no need for inputs in nurseries and no planting of seeds or seedlings. During the harvesting process, low numbers of stems are taken out and canopy closure is much desired and retained as much as possible to create the microenvironment where the timber trees are more likely to regenerate. So natural regeneration, or the seedlings and the saplings, particularly of the commercial tree species, are protected during harvesting operations. Okay, so these natural regeneration systems take place in an uneven-aged forest. In an even-aged forest, you wouldn't need natural regeneration systems because it is basically a replacement or plantation system. But natural regeneration systems are very appropriate in uneven-aged forests, where the stems or the trees which you want to harvest are right next door to the regeneration, the next crop of timber which is going to be harvested. So you have to protect that natural regeneration during harvesting operations. Because you want to keep that closed canopy, and therefore you go with a low density of stems taken out, and you also need to protect your regeneration to a certain extent, returns on your initial harvest tends to be much lower, and it tends to be lower than if you go in there and just take everything without regard for protecting regeneration or keeping the canopy closed. So the initial returns on harvest are lower, but because you are considering future harvests and stuff, the costs of long-term management are less and rotation time is shorter. And a very important factor of natural regeneration systems is that the capital outlay, or the amount of money that you need to put in to manage the system, is very small. Well, it really is restricted to harvesting operations, because you're harvesting in such a way that you preserve the ecosystem processes. You don't need to plant or raise seedlings. You don't need to go in and thin, and that means that your costs for this particular timber management system are very low. So even though the return is lower, the costs are lower, and in some cases this can balance out and mean that you will have just as much of a return as you would in a plantation system. But that's really only in forests where you would have a larger number of natural timber species or species which can be utilized in your forest. Now, because you're trying to disturb the forest as little as possible, this is the best timber production system for other tropical forest uses. Because the biodiversity is maintained in the forest and all the ecosystem processes are maintained in the forest, then all the other values or services or goods which this forest can provide are still preserved. So hunters can go back into that forest and still find all the game animals because all the food trees for the game animals are left behind. Conservationists can go back into a natural regeneration forest and still find all the biodiversity preserved. So natural regeneration systems tend to be very good for multiple use forests. That, coupled with the fact that you need a much smaller capital outlay, makes natural regeneration systems of great interest to government managed forests. If you can manage your forest under a natural regeneration system, then you can please the maximum number of stakeholders and still get a return from timber production. So the government of Trinidad and Tobago have put in place a natural regeneration system down in the Victoria Miara Forest Reserve. It's called the periodic block system, and it's been running for 30 to 40 years now, and it is shown that if it is done properly, these blocks can be ready for harvest up to 30 years after they've been harvested initially, and there is no reason to believe that that harvest cannot be sustained in perpetuity. Although, as we will hear from Mr. Carlton Roberts in a later lecture, his PhD research is looking at exactly that question. What is the growth rates of the trees? How long do we need to leave this forest before it accumulates the same amount of timber that you take out, and therefore prove the sustainability of the periodic block system in the Victoria Miara Forest Reserve. Another problem with natural regeneration systems, besides sustainability not being proven in the long run, is that value is not added to the forest. Because value is not added to the forest by enriching the forest with timber trees and so on, it means that the forest is seen as less valuable and therefore more vulnerable to conversion to non-forest uses. So natural regeneration systems can actually make a situation where people feel that that is just another patch of bush, another patch of forest, even though it has the potential to provide timber into the future sustainably. People just see it as an unimproved forest which has little or no economic value. So it is vulnerable then to conversion, maybe even to plantations, or conversion into oil industries, mining and so on, agriculture and so on. But natural regeneration systems are still popular amongst governments because, as I said, they cost the least amount to manage and they leave the forest available for many other different forest uses. Now, the biggest problem with management of natural regeneration systems is that during harvesting there is inevitably going to be damage to the ecosystem. So the idea of reduced impact logging is to try and minimize the amount of damage done, particularly to the regeneration in that forest, the seedlings and the saplings, but also to limit the damage to soil, reduce the amount of soil erosion, reduce the amount of blockage in streams, so that to reduce the amount of flooding where skid trails cross over streams and so on. All this damage will affect the capacity of the forest to maintain a sustained yield of timber into the future. There is direct damage mainly to regeneration and soil, and to a lesser extent the opening up of the canopy. Now, as we've seen in previous lectures, the opening of the canopy is undesirable for two big reasons. First of all, it does make the forest more prone to fire, and secondly, it does promote the growth of our selected species, which are usually not good timber species, and therefore delay the regrowth of timber in the forest, and therefore delay harvesting times. Now, damage limitation is a fairly common feature of managed uneven age temperate forests. So most of these principles of reduced impact logging have actually been worked out in places like the southeastern United States, where broadleaf hardwoods such as black hickory and oak are extremely valuable timbers. They're really valuable. So a single tree will cost tens to hundreds of thousands of US dollars. So it's in the best interests of people growing these trees to manage them correctly, to get a sustainable yield of that timber, and to minimize the time between harvests that can be carried out sustainably. So the principles of reduced impact logging have been worked out in these temperate forests, and basically their general objective is to reduce the damage to regeneration, so reduce the damage to seedlings and saplings, and to maintain a closed canopy, to maintain the growth of these seedlings and saplings, and in so doing minimize the time to the next harvesting event, and therefore maximize the return from the forest in as short a period as possible. So what are these different types of damage control? There's a basic damage control of harvesting operations. It doesn't need to be an expensive option. All you need to do is to try and restrict yourselves to behaving in a certain way in the forest to minimize the amount of damage. Now, reduced impact logging, although it was developed in these temperate broadleaf hardwood forests, much interest has been expressed in trying to translate these types of logging systems, these reduced impact logging systems, or RIL systems, into tropical forests. And many different tropical country governments have examined ways in which reduced impact logging can be instituted into their logging operations, or legislated into the contractors having to carry out reduced impact logging operations. Generally, there does tend to be some resistance of contractors to the imposition of IRL procedures, mainly because They are no longer free to just go in and do what they want, and there is very much a perception of much closer management and scrutiny on their operations, and this quite often is not what the contractors would desire. So enforcement of RIL regulations does tend to be a main problem for tropical forestry, particularly in developing countries, where the enforcement of these regulations is actually quite often lacking, even though the regulations are in place, mainly because getting people out into that forest does tend to be quite a challenge. So the basic damage control of harvesting is not expensive, but enforcing it can be a bit more problematic. Now, as I've said before, reduced impact logging has been seen to be a good way of logging in tropical forests, but there has been some resistance from contractors, and in some cases they have drawn up their own guidelines for reduced impact logging to reduce impacts in different places. So places like Malaysia may have one set of reduced impact logging which is government approved. Guyana has another set of guidelines. Trinidad, would you believe, actually has another set of guidelines as well. And standardization of these programs is something which organizations like FAO will try and UNDP will try and get underway. Alright, so what are these reduced impact logging? So some of the details of the procedures. The first thing to do with a reduced impact logging is some sort of silvicultural enumeration. A silvicultural enumeration is basically going into the stand which is to be harvested and locating accurately in the stand and marking down on a map where all the commercial timber trees are. When you have the locations of all these commercial timber trees, then you know where you need to go in the stand to harvest. And you can also see the densities of these commercial trees, and you know that you're not allowed to take more than, say, 2 or 3 in a hectare at any one time. Topographic surveys should also be carried out. This is because damage to forest soils is much greater on steeper slopes. So if you have a topographic survey, you can plan your skid trails in your stand so that you avoid steeper slopes. This will also mean that you can also avoid watercourses or minimize the amount of time that skid trails cross over watercourses. Now you want to try and do this because every time you cross a watercourse with your big heavy machinery, you need to build some sort of bridge, and that is inevitably going to block up that watercourse, and it will lead to flooding if you do it too much and you don't clean up afterwards. So topographic surveys allows you to plan out your skid trails, particularly if you know the actual locations of your commercial timber trees. You can very carefully plan out your skid trails and therefore minimize the amount of skid trails you need, and also minimize the number of times you cross watercourses and so on. So logging access roads, skid trails should be planned in advance to avoid unnecessary crossing of watercourses and steep slopes. From the 100% enumeration, all trees to be felled should be marked. So you go into the forest and you will mark in brightly coloured ribbons all the trees which have been sold and can be felled. And there should be directions marked on the trees which direction the tree should be felled. Now the reason why you should plan which direction you're going to fell the trees is to protect the seedlings and saplings which may be around the tree. The trees should be felled away from seedlings and saplings and pole-sized trees of commercial importance, and as much as possible the trees should be felled parallel or at a very shallow angle to the skid trail, so that when you drag that log out you don't have to turn the log, and if the log turns it's going to crush a lot more regeneration and affect a lot more saplings and so on than if you just pull it out from the end to the skid trail. So planning where you're going to fell the trees is very important and should be planned out. Okay, now contractors at the moment will tend not to plan out their logging skid trails and so on. So what would happen in an uncontrolled logging operation is that the fallers would walk into the stand and they would look for suitable commercial timber trees, and they will cut them down without any thought to densities, the areas where they're going to be cut down, avoiding other trees and so on, other commercial trees. They will just go into the block, into the stand, and cut down as many of the commercial trees above a certain size limit that they can find, or up to a certain limit which they're allowed to take out. Once that's been done, then the skidder drivers will just drive into the forest without any skid trails planned, and they will just drive around in the forest till they find all the felled trees, or as many as the felled trees that they can find, and they will just drag them out. So as you can imagine, the skid trails can go all over the place in the stand. They can cross the streams multiple times. They can traverse steep slopes, and much more damage to the regeneration is caused by this heavy machinery moving around in the forest than is necessary. But the contractors are used to this way of doing things, but it also means that they don't have to spend as much money on doing an enumeration or a topographic survey, and they can just cut whatever trees they come across. Alright, another reason contractors are not particularly enamored of the idea of planning falling directions of their trees once they've been cut is because quite often they will try and fall a tree against another tree and knock that other tree over, and when they do that they'll get two trees for the price of one, in effect. It's because they'll go to the forester and say, oh look, this tree got knocked down when I was falling the one that you allowed me to take, so I might as well take that one as well. And this is a fairly common practice, and as you can imagine, instead of having just a gap which is the size of one tree, you get a gap the size of two trees, or maybe even three trees. So the canopy is opened up a lot more than it needs to be. Alright, another pre-felling procedure, the last one I think, is that climbers and vines should be cut down before harvesting to reduce the pulling down of other trees during cutting. So vines and lianas and climbers will climb up into the canopies of the tree, and they will move from one canopy of the tree, and they will link the canopies of several different trees over an area with these vines. And these vines can be quite strong when they're fresh. Most of these vines will have roots going down to the ground, and once you cut those roots, then the climbers and vines will die. And when they die, they no longer link the different trees together. So about a month before harvesting, climbers and vines should be cut on all the trees which have been nominated for harvesting, so that those climbers and vines will die. And once you harvest that tree and it falls over, the climbers and vines don't pull down several other trees. So obviously contractors don't like this idea, because they are able to get more than one tree if another tree is pulled down when one tree is harvested. So this does need to be enforced, or even carried out by the forestry, or the forestry division, or the government landowner. Another reduced impact logging procedure, or another set, occurs during harvesting. So logging access roads and main skid trails should be along watersheds, in other words along tops of ridges, and roads and skid trails should have temporary bridges to allow water to flow to continue. And this is fairly easy to do. You throw a concrete pipe into the water channel, and then you can bulldoze the soil over the top of that to provide a temporary bridge. And once the harvesting operation is finished, you can put a chain around that concrete pipe and drag it back out of the forest and allow the watercourse to flow freely once again. Alternatively, you could leave that concrete pipe, although if it is left, it needs to be checked periodically so it doesn't get blocked and form a dam. If water flow is dammed, it can cause a swamp and the death of many trees, particularly trees along the watercourse, which does tend to be some of the main highly productive areas in the forest. So you don't really want to swamp those out and flood them. Contractors should be supervised to make sure that they adhere to the planned network of traces or skid trails, and they should be supervised to make sure that they are adhering to the directional felling indicated on the trees. So the trees must be felled in the direction which is nominated. As I said before, trees should be felled parallel with the skid trace or at a low angle, so it does not need to turn and crush regeneration. If you cannot fell the tree in a direction which is parallel, then the tree should be felled, and if it's perpendicular to the skid trace, and it will inevitably turn once you try and drag it onto the skid trace, then the log should be cut up prior to extraction into sections to minimize the damage during turning. Trees which hang up through vines once they're harvested, so even if you devine the tree, there may still be vines linking the tree, maybe from another tree around it, and the log is caught. It doesn't fall all the way to the ground, but it is hung up by those vines. What some timber cutters would do is use this as an opportunity to cut the other trees around the felled tree and take them out as well. But there is an alternative. Most skidders will have winches, and you can winch that tree down, and that will break the vines and bring that log down. Logs should be winched to a skid trail rather than the skidder being driven right up to the log. So the skid trails should be planned to go within maybe 20 meters of the log, and a winch cable can be run out from the skidder and attached to the log, and the log can be dragged out with the winch rather than the skidder having to drive through the forest and crush all the seedlings and saplings and pull the log out. So it's much better practice to winch the log to the skid trail and therefore minimize the damage to the regeneration. Alright, so after harvesting, compacted soil on the main skid trails and log loading points along the main roads should be ripped and if possible seeded with native pioneers so that the soil doesn't remain compacted and unavailable for regeneration. Watercourses should be cleared of any obstructions. If there are obstructions remaining, as I said, can lead to flooding and loss of timber trees because they die, because they cannot tolerate the swampy conditions. A post-felling timber inventory should be carried out to identify trees which potentially in 30 years' time may be harvested. Locations should be recorded, and that will help in the future when the next harvesting operation in that block or that stand needs to be carried out. An inventory of the biodiversity post-harvesting can also be carried out to assess the impact of logging on species other than trees in a logging coupe, but that's probably not going to be done by the logging contractors. That would necessarily have to be done by the government, who has interests of other users at heart. Now you may think that this sounds like a lot of carry-on and so on, but it does significantly reduce the amount of time between harvesting cycles if you protect that regeneration. It can also mean that the timber trees maintain their density in that forest, and that improves sustainability of the harvest. And these reduced impact logging procedures, they have been proven to be effective in these temperate forests. They're less carried out in tropical forests. Well, there's less records to show that they have been effective in tropical forests, but they should be just as effective in tropical forests as they are in temperate broadleaf forests. So I believe that FAO brought experts in to show or demonstrate reduced impact logging procedures to woodworkers in Trinidad 20 years ago. There wasn't really much uptake of that, mainly because Forestry Division didn't tend to enforce the reduced impact logging procedures. To enforce them effectively, there has to be punitive measures, such as the contractor not being allowed to bid for harvesting of a stand in the future if they don't adhere to the procedures. All too often the political connections of the contractor trumps the management, the proper management of the system by the Forestry Division. So it does work, and it should be paying attention to. Alright, restoration systems of timber production. Well, basically what this is productive forest being planted on unproductive degraded land. It's usually in the form of establishing plantations on agricultural land, and it requires the most inputs to get the forest growing, because you need to prepare the site, you need to modify the site to make sure it is suitable for planting trees, which means clearing away seedlings, ploughing and ripping to make sure that there's no compaction of the soil and lack of water penetration. You also need to provide the seedlings and plant those seedlings, which can be very expensive. At the end of it, the restoration systems can have a similar sort of return as clearing systems and even plantation systems if you use just timber species all the way. An example of a restoration system, well, pine plantations on Mount St. Benedict, where pines were planted on degraded grassland on those slopes up there. It's probable that these pines will never be harvested because they're not that big to begin with, but also because they're on quite steep slopes, so it would be quite difficult to get them out. And one of the objectives of planting them up there was really to provide the illusion of a forest being restored to those slopes. Planting a 15-year Colombian cedar on abandoned agricultural land is another example in Trinidad. So one way in which you can improve the value of your old estate is to plant timber trees on it, and that is effectively a restoration system. Okay, so those are some of the timber production systems that are used in tropical forests around the world. Thank you very much.